Arithmetic and geometric series including summation notation. Well, let's take, for instance, this geometric sequence. 3 times 2 times 2 times 2 times 2. The series is actually if you were to add them all together. So let's see what we'd get. 9 and 12. So was that 21, 60, 72, 93. Well, I know you're like, that wasn't terrible, but you know mathematicians, they like having formulas. So they came up with the two formulas. Now, S sub n just stands for sum. Now, first I'll show you arithmetic and then geometric. Arithmetic is number of terms, first term plus last term, divided by 2. Geometric, the sum is first term, 1 minus ratio to the n power over 1 minus r. So since this one we said was geometric, let's plug in the formula just to see, to verify it works, and so you can see how to plug it in. First term, 3. 1 minus ratio was 2. 1, 2, 3, 4, fifth power, all over 1 minus ratio, which of course was 2. So 1 minus 32, so 3 times negative 31 over negative 1, 93, which I'm sure you didn't doubt me. But as you can see, it works. Now let's take an arithmetic. Let's say 8, 10, 12, 14, 16, 18. We want to add the sum of the first 6 terms. Number of terms, and I'm going to show you something interesting in just a minute, kind of where it comes from. Number of terms, 6. First term, 8. Last term, 18. Divide by 2. So 26, 2 goes into 6 3 times, 78. And sure enough, if you were to add them all up, it would be the same. Now, I know you're thinking, why would I, if I had them all listed, why would I add them up? Well, see, most of the time they don't. Let's say that they actually gave you a formula, something like 5x, or we'll even put an n, 5n plus 3, where they wanted the sum of the first 10 terms. Well, you might be like, okay, what kind of sequence is this? Well, let's do a couple and find out. And then I'll show you a shortcut. If you plug in 1, for n is 1 for first term, you get 8. For when n is 2 for second term, you get 13. When n is 3, 15 and 3, 18. Notice it's an arithmetic and you're adding 5 every time. So if it's ever a number or n to the first power, it's arithmetic, and your ratio, or rather your difference, is the number out front. So if you wanted to find the sum of the first 10 terms, it's, remember, number of terms, 10. To find the first term, you just plugged in 1 to get 8. To find the 10th term, you just plug in 10 to get 53. Divide by 2. So 61. And you could say times 10, 610 divided by 2, 305. Or you could say 2 into 10, 5, and get 305 that way. So if you had like, or x or whatever, 4n minus 7, arithmetic difference of 4. Now let's say you have something like this, or 2 to the n. We'll still stick with n. Well, notice how if you plug in 1, 2 to the first, 2 squared, 2 cubed, 2 to the 4th, how are you getting to each term? You are actually multiplying by 2. So when you have a constant to an n power, it's actually a geometric sequence, and that is your ratio. So even if you had something weird like 4 times 3 to the n power, it's geometric and your ratio is 3. So like if I wanted to find the sum of the first 12 terms, first term, so 2 to the n, 2, 1 minus ratio, which happens to be 2, to the n power, so 12th power, over 1 minus 2. So we've got 1 minus 2 to the 12th, negative 4,095 times 2, and it's over negative 1, so it's just going to be 8190. If it was 1 like this, you would do it the same way. Because remember, I should have written the formula for you again, but here's the number, or here's the formula. So first term, plug in 1, 3 to the first times 4, 12. 1 minus 3, and we'll still stick with the first 12 terms. So 12 over 1 minus ratio. Oh, sorry. And that should go there. So 1 minus 3 to the 12th times 12 divided by negative 2. You can see geometric get really big, really fast, about right under 3.2 million. So very easy formulas to work with. Now let's say you had something like this. This is called summation notation, where you start with this number, in this case is 1, and then you end at 3. So you're going to plug in 1, you're going to plug in 2, you're going to plug in 3. So 9, 13, 17, add them all up, 39. It's called summation notation. Now you can also do it if it was like x equals 7 to 12 of 2x. You just start with this number, so 2 times 7, 2 times 8, 2 times 9, 2 times 10, 11, stop at 12. So 14, 16, 18, 20, 22, 24. So you got 30, 38, 46. So what is that? 76 and 38, 114. And notice how you could even do, let's do one more regular one. Let's do a negative number to a 1. And we'll say 3x plus 1. It's the same exact thing. You start with this number. You're going to plug in negative 2. And you're going to go up to 1. You've got to include 0. You've got to stop at 1. So negative 6 and 1. Negative 3 and 1. 0 and 1. Add them all up. Negative 2. Now you might be like, why are we doing this with summation notation? Well, that is because if they give you something, like for instance, summation of 1 to 50 of 6x minus 3, they obviously don't want you to go through 50 times. Remember, this is just an arithmetic sequence with a difference of 6. So your formula was the sum equals the number of terms, which in this case is 50. First term, you plug in 1, 6 minus 3, plus last term, you plug in 50. 300 minus 3, 297, divide by 2. This one works out nice. 300, 2 into 50, 25, 7,500. There you go. Is that right? Yeah. 1, 2, 3. Yeah, 15,000 divided by 2. Same thing if they gave you something like this, and they wanted to know what is the sum. You can be like, oh, well, that's a geometric one. So first term, 1 minus r to the n over 1 minus r. So first term, 4. 1 minus 4 to the 11th power of 1 minus 4. So 1 minus 4, 11th power, times 4, divide by negative 3, 500, or I'm sorry, 2404, right under 5.6 million. So that's how you can also use series in combination with summation notation. Sorry that was a little long, but didn't want to assume that you knew how to do summation notation before I threw that in there to you. Have a great day.